Welcome to the video for the mat050 final review worksheet, page 8. We'll start with question 19, which accidentally got put on page 7, but the problem itself is on page 8. So 19, the following table shows the cost of a family's cell phone plan based on the amount of data used over the data limit. So the amount that they go over the limit is the cost. So if I look at the table, first of all, they didn't use 0 megabytes of data. They used exactly their limit here at the cost for $170.91. That means they used exactly their limit. This one means they went to their limit and then went 10 megabytes over their limit. So first of all, we have to explain why a linear equation is appropriate for this relationship. Linear equation, when the x value goes up by a given amount, with a linear equation, the y value goes up by the same amount. So we look at the linear equation. From 0 to 10 is 10, from 10 to 20 is 10, from 20 to 30 is 10, and then it's 10 from 30 to 40. So this is going up by 10. We want to see if this goes up by the same amount also. And that's a little, I can kind of see it's going up by the same amount, but it's kind of hard to see. So I'm going to plug those numbers into the calculator just to make it a little more obvious. So I take 190.81 and I subtract 170.91 and I get $19.90. The calculator doesn't know it's cents, so it didn't know to put the 0 there, but that's 90 cents. I'm going to do the same thing again. I'm going to try 210.71 minus 190.81, and I get 19.9. And if you want to show that on your worksheet, that helps, but the main thing you want to say, it's a linear relationship because it goes up by a constant amount. And again, on your paper, you won't have the problem of writing on the screen. You can write that entire sentence out. Find the slope of the line and explain what it means. And I can actually use some of the data that I just did. I'm going to take the 2 points. So my slope is change in y divided by change in x. So m equals, I'll write that. The triangle means change. And change or difference comes from subtraction. So I'm going to take my y. I'll take the 190.81. I'm going to divide by, I need to subtract 170.91. It's a decimal point. And I'm going to divide that by change in x, which is, and where I took 190.81 as the first y, I have to take 10 as the first x. It becomes important when you have a relationship where it's going down. A lot of people try to make a positive number every time. In this case, they're both going to end up being positive because I have 10 minus 0. So I'm going to have that $19.90 that I got before when I subtracted 190.81 minus 170.91. I got 19.9. I'm going to divide that by 10. And because 10 minus 0 is 10, so I have 19.9 divided by 10. That's, I'll put in my dollars, 1.99 dollars per megabyte. It's my slope of the line. And for my explanation, I'm going to say that's the amount that the cost increases with an additional 1 megabyte of data use. So if the x increases by 1, this is how much the y increases by. C says find the y-intercept. Okay. And on this one, it's pretty easy because we've got the table. A lot of times you can use the slope to calculate the y-intercept, but in this case, we just know that the y-intercept equals 170.91, and that is because that's where x equals 0. To find the y-intercept, you have to find what happens when y equals 0. And we're given that in the table. Determine the equation of the line, D. Now that we have the slope and the y-intercept, that's relatively straightforward. Y equals mx. M is the slope. So that's 1.99. X plus b, which is the y-intercept. Trying to make a decimal point. That's my decimal point. Okay. E, what will the planned cost if the family goes over their limit by 32 megabytes of data? We can use our equation now to do that. Cost is going to be y. It's going to equal 1.99 times x, which we now know. We're told x is 32 megabytes. So we can multiply by 32 instead of just writing the x. We do plus 170.91. Okay. And we'll see what that equals. And at this point, I just put that in the calculator. 1.99 times 32 plus, and my calculator I think goes from left to right. It doesn't do a very good job of PEMDAS, but I want to multiply first, and I'm doing it anyway the way I've set up the equation. So I can say plus 170.91, and that's going to give me $234.59. $234.59. Okay, that's a decimal point. Trust me. Okay. Well, great. The younger sister decides she needs that app too. Also determine what the plan will cost if you go over by 64 megabytes. And some people are tempted to multiply this by 2, but when you do that, you will double your y-intercept. So we actually have to do 1.99 times 64. And then add the y-intercept. So only the 1.99 gets doubled. Once again, use your imagination Pretend that's a decimal point. Okay. And I go to the calculator. $1.99 times 64 plus 170.91 equals 298.27. Okay. All right. Go ahead and pause the video now, please, and look at question 20. After you've had a chance to think about question 20, let me turn the video back on, and you can see if your solution agrees with mine. Okay. All right. Now that you've thought about question 20, Kelly and Kellen own a food truck that makes and sells gourmet corn dogs. They have determined that they will have $1,400 in fixed costs. Each corn dog they sell uses cornmeal, oil, and a hot dog, which costs a total of $1.50 per dog. So the total cost can be calculated using the formula 1,400 plus 1.25D, where D represents the number of corn dogs sold. They typically sell each one for $4.50, so the revenue can be calculated using the formula R equals 4.50D. Okay. In this problem, they've done a lot of the work for you. They've actually written the equations. And if you look at the cost equation, you've got the 1,400 there. That comes from the fixed costs. It does not depend on the number of hot dogs, the number of corn dogs sold. And the $1.25 comes from here where it says per corn dog, $1.25 per corn dog. So every corn dog costs that $1.25. You have to multiply by the number of corn dogs to see how much you're going to have after, or how much the cost is going to be after that number of corn dogs. So, and then revenue, typically they sell each one for $4.50. So $4.50, you multiply that by D, the number of corn dogs, because you get $4.50 for every corn dog. You get $4.50 D times. So you multiply 450 times D. All we're asked to do here, though, is write the algebraic equation that demonstrates the cost is equal to revenue. Solve this equation and explain the meaning of the solution. So cost equals revenue. It doesn't in general, you hope the cost is less than the revenue, but we're asked to see where it equals the revenue. So I'm going to take my cost equation, and I'm going to say it's equal to the revenue equation solve this equation and explain the meaning of the solution. So I'll solve the equation. I'm going to combine like terms. Typically, we subtract the number that's by itself, the 1,400. We subtract that and get it on the other side. But you'll notice I have D on both sides. And I don't want that. I want the D's all together. So I'm going to subtract 1.25D from both sides. That's going to leave me 3.25 3.25 D equal to 1400. Now run out of room. So I'll divide by 3.25. And the 3.25s cancel on the right-hand side. I end up with D equals 1400 divided by 3.25. And the number of corn dogs equals 431. So over here I will write corn dogs and if I had more room, and you should, because you should have more room, you want to write that this number, this means this is the number of corn dogs that they need to sell so that they make enough money to pay their costs. It's what's called the break-even point. They actually want to make more money than this. They want to sell more corn dogs, but it's good for them to know they have to at least sell 430 corn dogs. And that's going to be useful in question B, because question B wants us to write an algebraic inequality to indicate that the cost is less than the revenue. So we want the cost to be less than the revenue. Solve the inequality and explain the meaning. So we want cost to be less than revenue. And I'll go ahead and write the same thing again. Our cost is 1400 plus 1.25 D. And I want that to be less than 4.5 0D. Okay. And same thing, I subtract 1.25D from both sides. And that leaves me 1400 being less than 3.25 D. So my inequality really parallels my equation. And once again, I'll divide by 3.25, and I'm going to get 431 has to be less than D, or D has to be greater than 431.